Good morning to everyone, Paul. Today we are going to see about the diesel cycle. Right? So in previous class we discussed about the Otto cycle, which is used for a petrol engine, right? So based on this cycle, all the diesel cycle engines are operated. So that is the thing. So in case of diesel cycle, again we have to considering what are the process are involved in this cycle. So here the first process is, again we are considering a reversible adiabatic compression process. Okay, compression process. And second one is, actually in the case of a diesel cycle, we are considering a four various cycles. In that, two are reversible adiabatic process. One is compression, another is expansion. Rest will be a constant pressure process, sorry, constant volume process, where heat addition and heat rejection takes place, right? And here heat heat addition takes place at constant pressure. Okay? Heat addition takes place at constant pressure process. And third process, again you are considering a reversible adiabatic expansion process. Okay, and fourth one is a heat rejection, which takes place at constant volume process. Okay, so these are the four processes involved in the diesel cycle. Okay, so first and third process is a reversible adiabatic process. Already we know that, otherwise we can say is a isentropic process also, right? Otherwise called isentropic process. So in that we are having a two process. One is a compression, another one is a expansion. Okay, and heat pressure process, where heat addition takes place, and final process is a constant volume, where heat rejection occurs. Okay, so these are the four various process involved in a diesel cycle. Okay, then so just we need to plot a PV diagram and TS diagram for this cycle. Okay, first we will plot PV diagram. So PV, that is pressure, volume, and we need to plot TS diagram. So where T is nothing but temperature and S is nothing but entropy, right? So the first process is reversible adiabatic compression process. So we know that in the case of a compression, what will happen? In the case of a compression, definitely because of compression, pressure get increased. Pressure is directly proportional to temperature, so temperature also get increased. And which is a reversible adiabatic process. We know that always during the isentropic process, the entropy must be constant. And one more parameter, volume. If pressure get increased during the case of a compression, definitely volume get decreased. Okay, so the first process, So it's maybe it takes like this 1 and 2. Because of compression, pressure get increased from this position to this position. Simultaneously volume get also get decreased. So if pressure get increased, here temperature also get increased. The process takes place between 1 and 2. And second process is heat addition at constant pressure, right? Heat addition at constant pressure. So we can plot like this. Okay, we can plot like this. So the process between 2 and 3 we can say it's a constant pressure process, so we can plot like this. So because of even you are considering the process is constant pressure, heat is added continuously to the system. So because of addition of a heat, temperature definitely get increased, so that we can plot like this. So here also, because of heat addition, temperature get increased. Okay, so here also the heat addition. And third process is reversible expansion. So because of expansion, the temperature, sorry, the pressure get decreased, right? Temperature, sorry, pressure get decreased, so that temperature also get decreased. Okay, because of expansion, there is no need to give any external work for the expansion process. So in the case of engine, actually the power stroke will be generated in the expansion process itself. So we can say which is a work done by the system. Work done by the system. Already we discussed in previous auto cycle itself what is meant by work done on the system and by the system. Work done on the system means some amount of external work is needed to operate the cycle. What is work done by the system means some amount of power is given or produced by the system, right? So actually power is generated here. So here we are giving us by the system. For operating a compressor, we need to give some amount of external work. So we are using a on the system. And final process is a heat rejection. So in the case of a heat rejection, definitely the temperature, sorry, get decreased. Temperature get decreased. And here the process you are considering as a constant volume. So you can plot like this. Okay, here heat rejection takes place. So temperature also get decreased. So here heat rejection. Okay, so this is the PV diagram or DS diagram for a diesel cycle. I hope all of it clear, right? So and both are adiabatic, reversible adiabatic process. Okay, so here is work done, work in, that is work done on the system. Here work out, that is we are work done by the system. Okay, and which is volume constant here. Okay, during the process between 2 and 3, pressure is constant. Okay, fine. And in the case of a diesel cycle, right? So already we discussed in the auto cycle, we are introducing two new terms. One is a compression ratio, another one is a expansion ratio, which is nothing but V1 by V2 is a total volume cylinder to the clearance volume, and expansion ratio, that is V3 by V4. Here we are introducing another new term, that is cutoff ratio, right? So cutoff ratio, which is denoted by the symbol rho. So what is cutoff ratio is nothing but actually at the end of the compression stroke, right? At the end of the compression stroke, heat is added from the certain body, right? At a constant pressure. During this addition of heat, actually volume get increases. Okay, so actually volume get increases from 2 to 3, and temperature also increases from 2 to 3. Where the maximum temperature occurs, so where the maximum temperature occurs, that point we can say as a cutoff point. Okay, so where the during constant pressure process heat is added to the system, so where the maximum temperature is obtained, that is called cutoff ratio or cutoff point. So that is denoted by in the symbol rho, which is nothing but cutoff point, right? So the cutoff point is defined as the ratio of uh, where the volume is here, right? See, V3 divided by V2, that is cutoff ratio. Already you know that what is compression ratio is nothing but denoted by the symbol R, which is V1 divided by V2. V1 divided by V2, that is V1 is nothing but this is thing. Okay, so here we can say as a V2, the whole thing is here V1. Okay, and this up to this position we can say as a Vs. Okay, so V1 is nothing but total volume cylinder. V2 is nothing but this position. What is that? Clearance volume. Okay, and likewise the expansion ratio also denoted by the symbol R. The expansion ratio takes place between 3 and 4. We are so that we can say as V3 by V4. Actually, volume V3 by V4. Okay, sorry, the volume is higher here, right? So V4 by V3. Sorry. Okay, pa. So let's see. Actually, we discuss in the auto cycle itself. Actually, we need to derive three various parameters. So the first one is we need to derive an expression efficiency of diesel cycle. Okay. So the first parameter we need to derive an expression for efficiency. So generally we know that the formula for efficiency, which is denoted by the symbol eta. Okay. The general formula for measuring efficiency is nothing but work done divided by heat supplied. So work done is nothing but a net heat supplied. The net heat supplied we can say as a difference between the heat supplied. Sorry, work done is nothing but net heat. Net heat is nothing but here difference between the heat supplied and heat rejection. Okay. So again, so you know that the general formula for Q, which is mCp del T. So here considering the heat supplied, actually the heat supply takes place at a constant pressure process where the temperature takes place between where 3 and 2, right? The process takes place between 3 and 2. So we can say as T3 minus T2. Okay. And heat rejection, again M, actually heat rejection takes place at constant volume, so you can use like that. The temperature difference between T4 minus T1. Okay, the process between 4 and 1. So simply substitute here eta equal to mCp T3 minus T2 minus of MCV T4 minus T1. Again, the heat supplied is MCP T3 minus T2. Okay, fine. Okay, so from that, uh, so we can split like this. Actually, the denominator is common, so numerator and denominator term is common, so we can getting cancel one. So remaining thing is here MCV T4 minus T1 divided by MCP T3 minus T2. So here also most get cancelled. So where we know that gamma, which is a ratio of a specific heat of the constant pressure to the specific heat at constant volume. So you can replace here 1 minus, so instead of Cp by Cv, you can substitute gamma. So actually here Cvb by Cp, so we can substitute 1 divided by gamma. Okay, so the remaining term is again the same, T4 minus T1 divided by T3 minus T2. Okay, so this is a efficiency formula for diesel cycle in terms of temperature. In terms of temperature. So if you want to simplify the efficiency equation, again you need to replace the temperature term. Instead of that, you can substitute some other new terms like in terms of compression ratio, cutoff ratio, or expansion ratio like that. So we will see that how can you replace the temperature terms for simplify the equation. Okay, see. So instead first you have to consider the process between 1 and 2. Actually, the process between 1 and 2, which is nothing but reversible adiabatic compression process, right? So, because of adiabatic process, the general equation, which is nothing but PV power gamma equal to C. So, because of the process between 1 and 2, you can say like that P1 V1 gamma equal to P2 V2 power gamma. So, just you can replace the term. So, the general gas equation is PV by T equal to C. So instead of temperature, you need to replace the another terms. Okay. So instead of pressure here, instead of pressure, so P equal to T divided by V. You can substitute here. See, already we solved this derivation of for T2 already in auto cycle itself. So once again repeat here. Okay. So instead of P1, we can substitute T1 divided by V1 into V1 power gamma equal to like P2 T2 divided by V2 into V2 power gamma, right? So we can say like that T1 into V1 gamma power minus 1. So because of if you move from denominator to numerator means we can say like that. And T2 equal to again V2 power gamma minus 1. So actually here instead of T2 we can form like this. T2 equal to T1 into V1 divided by V2 power minus gamma, right? So already we know that V1 by V2 is nothing but compression ratio. Since R equal to V1 by V2, we can substitute T1 into R power gamma minus 1, right? So maybe we are considering this is a equation number 2. Okay, this you can consider as a 1. So next, you have to considering the process between 2 and 3. So actually, what is the process between 2 and 3? So between the process 2 and 3, actually constant volume process, right? Sorry, constant pressure process, right? Constant pressure process. So the general formula for constant pressure is, which is nothing but PB by T equal to C. So here considering the process between 2 and 3, so you can say like that P2 divided by T2 equal to P3 V3 divided by T3. Here process we are considering as a constant, so pressure P2 equal to P3. Okay, they get cancelled here, so both are common. So remaining term is here V2 divided by T2 equal to V3 divided by T3. So from that again we need to measure some other parameter, that is T3 equal to, so we can form like that. Okay, T3, so V3 divided by V2 into T2. Okay, so instead of V3 by V2, V3 by V2 is nothing but already we in starting of the section itself we introduced the new term, that is, what's that, which is cutoff ratio. So instead of cutoff ratio is nothing but ratio of V3 by V2, so you can substitute cutoff ratio. So already measured at T2, see here. So from the equation 2, right? So from equation 2, just you can substitute instead of T2 as what that, T1 into R power gamma minus 1. So the final term is T3 equal to T1 into rho into R power gamma minus 1. So this is equation number 3. Okay, fine. Likewise, again, so next we need to consider the process between 3 and 4. Okay, just a minute, I will change the color. Okay, so just considering the process between 3 and 4. Okay, again the 3 and 4 is nothing but reversible adiabatic expansion process. So again we are considering the same formula, P3 V3 power gamma equal to P4 V4 power gamma. Okay, right. So again from this, again you can replace the term instead of pressure in terms of temperature. So instead of P, again you have to consider the general gas equation PV by T equal to C. So instead of P you can substitute T divided by V. So T3 V3 into V3 gamma equal to T4 V4 into V4 gamma. Okay, so T3 divided by T4 equal to, we can say T3 T4, and here V4 divided by V4, sorry, divided by V3 whole power gamma minus 1. Am right? Okay, right. So again, please listen here. There is a small expression change. Please listen carefully here. So from the, if you consider the PV diagram, right? So just to consider from PV diagram, right? We know that actually the process between 4 and 1, which is a constant volume process, right? So which is nothing but V4 equal to V1. Since constant volume process, okay, V4 equal to V1. So see here, just V4 by V3, which is equal to, instead of V4 we can substitute V1 divided by V3. So just multiplying with the term V2 divided by V2. So just for a simplify the equation, so just you can rearrange the above equation as V1 divided by V2 into V2 divided by V3. So from that, already know that instead of V1 by V2 we can substitute, which is nothing but compression ratio. V2 by V3 is nothing but what's that, cutoff ratio, right? So see, just to substitute here, instead of T3 by T4 equal to, so instead of V4 by V3, okay, already we measured something that the relation is nothing but, or sorry, so just a minute, actually cutoff ratio is V3 by V2, right? So here V2 by V3, the cutoff ratio is actually V3 by V2. Okay, please note here. So actually we here V2 by V3. So instead of a product, maybe you can substitute 1 divided by rho. Okay, so if you substitute here, instead of V3 by, sorry, V4 by V3, or divided by rho power gamma minus 1. Okay, right, and T3 equal to T4, sorry, um, T4 equal to T3 divided by r power rho power, sir, r by rho power gamma minus 1. So already we measured instead of T3, right? Just we can substitute the term, instead of T3, T1 into rho into r power gamma minus 1 divided by r divided by rho power gamma minus 1. Okay, so which is nothing but so T1 is again it will be repeated. So r power gamma minus 1, here we have a r power gamma minus 1. Okay, and which is gets cancelled. Okay, and here simply we have a rho, here rho power, actually rho power gamma minus 1, which is 1 divided by, if you move here means again we can form like this, right? See, it may be form like this. See, already here we have a row, so from there means again we'll get it like this, right? So we can split like this, rho power gamma, rho power gamma, sorry, we can write like this, rho power gamma into rho power minus 1. So actually here rho power plus 1, so both these term get cancelled, so remaining term is here rho power gamma. So T1 into rho power gamma, this is the final thing, T4. So T4, which is nothing but T1 into rho power gamma. This is equation number 4. Okay, right. So now we can substitute equation number 2, 3, and 4 in equation number 1. 2, 3, 4 in 1. So equation 2 is nothing but T2, T3 and T4. Okay. So the general diesel equation is in terms of temperature 1 minus what's that? T4 minus T1 divided by gamma into T3 minus T2. So just you can replace the term T4, T3 and T2. Okay. So 1 minus. So instead of T4, see here. So substitute the equation number 4. Instead of T4, T1 into rho power gamma minus. So again you can keep the same T1 divided by gamma. So instead of T3, so just refer the equation number 3. Instead of T3, you can substitute T1 into rho into R power gamma minus 1 minus of instead of T2, already we measure instead of T2 is nothing but just you can refer the equation number 2. So T2 is nothing but T1 into R power gamma minus 1. Okay. So you can refer the equation number 2 for this. Okay. So from here, so again 1 minus. So here T1 parameter is common. So please taking commonly outside as a T1 and remaining term is rho power gamma minus 1 and in denominator. Okay. See here also T1 into R power gamma minus 1 is common, right? So T1 into R power gamma minus 1 is a common in both the case. So simply you can taking commonly outside as T1 into R power gamma minus 1. So the remaining term is a rho minus 1, right? Okay, fine. And next step is here T1 and T1 is common, so get cancelled. So 1 minus 1 divided by gamma into R power gamma minus 1 into, so we can say remaining term is rho power gamma minus 1 divided by rho minus 1. Okay. So this is the efficiency expression for a diesel cycle in terms of what's that, compression ratio and cutoff ratio. In terms of compression ratio and cutoff ratio, this is we can given the equation number 5. Okay, the first parameter we derived. So next one is a work done calculation. So next work done calculation. See, so actually here in the process, first process work done between 1 and 2. So the work done between 2 and 3 plus work done between 3 and 4 plus work done between 4 and 1, right? Already know that if the work done on the system mean, what is the symbol used for that? What is the work done by the system? You are using the symbol. On the system means some amount of power is we need to supply from external. So we can use as a negative. By the system means some amount of power is generated by the system. So you can use positive sign. Okay. So actually work done on the system which takes place in the process, right? That is a compression process, and 4 to 1 which is a expand process. So here we are using the same positive sign and here is a negative sign. And what is the process? Sorry, 1 and 2 is a compression process and 4 1 is a, 3 to 4 is a expansion process. Sorry, 4 to 1 is a constant volume process and 2 to 3 is a pressure process. Sorry. And if the compress because of compression process we can say work done on the system, so definitely we can use the sign as negative. Okay, the process takes place between 2 1. So generally we know that what is the polytropic process. So based on that you can give the equation for your work done. P2 V2 minus P1 V1 divided by gamma minus 1 plus, and here work done takes place between 2 and 3. Actually the process we can say is a constant pressure process. So the work done for a pressure which is nothing but P into the process takes place between 2 and 3. So we can use the term V3 minus V2. So actually P2 equal P3, wherever you can use the equation P2 or P3, no problem. So please you can use the term P2 because of constant pressure, whatever the term you can use, whether you can go for a P3 or P2. So for a simplification process here you can consider as a P2. Okay, and for expansion process which is work done by the system, so you can use a negative positive. The P3 V3 actually volume is higher here, so you can consider like this, minus P4 V4 divided by gamma minus 1. And final process is constant volume process. Maybe already you discussed in the thermodynamic thermodynamics itself. So the work done calculation for constant volume is nothing but because of constant volume, whether you can consider say V1 V2 equal to, so you are saying is a 0. So here 4 1 equal to 4, V4 equal to V1. So the volume work done is for constant volume process always 0. Okay, just you can rewrite the rearrange this equation like this: P2 into V3 minus V2 plus P3 V3 minus P4 V4 divided by gamma minus 1 minus of P2 V2 minus P1 V1 divided by gamma minus 1. Clear? Okay, just I am rewrite the above equation and form like this. So please listen carefully. What are the parameters need to change here? Okay, see, actually it is taking commonly outside as a P2. P2, we know that since, see, the cutoff ratio is nothing but denoted by the symbol rho, which is nothing but ratio of V3 by V2. From that, instead of V3, we can form like equation like this: V3 equal to rho into V2. So simply substitute here, instead of V3, you can substitute rho into V2 minus V2. Okay, plus next P3. So again the same thing, instead of V3, you can use this equation as rho into V2 minus of P4, and instead of V4, so actually because of constant volume process V4 equal to V1, right? V4 equal to V1, and also you know that the compression ratio R equal to V1 by V2. So from that V1 equal to R into V2. Okay, so instead of V4, which is nothing but V1, so here instead of V4, simply you can substitute R into V2. Okay, divided by gamma minus 1. minus of P2 V2 minus P1. So already we discussed V1 is nothing but R into V2, just to substitute here, divided by gamma minus 1. Okay, right, done. So see here, all the volume parameters we make into in terms of V2. See, okay. So please take in commonly outside as a V2. So P2 V2 into, what is the remaining term? Rho minus 1 plus P3 into rho V2 minus P4 into or V2 divided by gamma minus 1 minus of P2 V2 minus P1 into or V2 divided by gamma minus 1. So please follow the equation, otherwise we can miss the sign notations. Okay, see. Just you can rearrange the equation like this: V2 P2 into rho minus 1 plus, what is the, already we taken commonly outside V2, so P3 into rho minus P4 into R divided by gamma minus 1, because already you can commonly taking outside V2 minus of, what is the thing, P2 minus P1 into R divided by gamma minus 1. Okay, right. So next step, V2, just taking LCM here. Okay, the denominator we having a gamma minus 1 into gamma minus 1, so taking commonly as LCM as a gamma minus 1, so we get P3 into rho minus 1 into gamma minus 1 plus P3 into rho minus P4 into R, okay, minus of P2 minus P1 into R whole divided by gamma minus 1. Simply I am taking a LCM here so that we can form the equation like this. Okay, so next step, V2. So actually process between 2 and 3, right? The second process is a constant volume process. So constant volume process, which is nothing but, because of constant volume process, P2 equal to P3, right? So instead of P2, here I am substitute as a P2. So sorry. Okay, already here we have a P2. I make a mistake here. It is P2 only. So no need to use these relations here. So V2 into P2 into rho minus 1 into gamma minus 1 plus P3, just here taking commonly outside is P3, and remaining term is rho minus P4 divided by P3 into R. So listen carefully here, P3 taking commonly outside. so that I form like this, minus of, again here taking commonly outside the term P2 for simplification process, P2 into 1 minus P1 divided by P2 into R whole divided by comma minus 1. Okay, then instead of the term P4 by P3, you can replace the some relations. Like similarly, instead of P1 by P2, you need to substitute some relations. So you can consider the process between 3 and 4. So because of here the process P4 by P3, so we are considering the process between 3 and 4. So which is reversible adiabatic expansion process. So that P3 V3 gamma equal to P4 V4 gamma. You can use this relation. So actually we need P3 divided by P4. Okay, P3 divided by P4. So P3 divided by P4, which is equal to V4 divided by V3 whole power gamma. Right? See here. So actually we need a P4 by P3, right? So just you can rearrange the equation. P4 by P3 equal to V3 divided by V4 power gamma. So actually we need a equation instead of P4 by V3. So simply rewrite the equation here. So already you know that because of constant volume process, V4 equal to V1, right? So V3 divided by V4 equal to, we can say V3 divided by V1, simply multiplying the term numerator and denominator as V2 divided by V2. So we can form an equation like this, V3 divided by V2 into V2 divided by V1. So we know that compression ratio is V1 by V2 and V3 by V2 is nothing but rho, cutoff ratio, right? So instead of V3 by V2, you can substitute rho, that is a cutoff ratio. Instead of V1 by V2 is a rho, actually here V2 by V1, so that we can say as 1 divided by R. Okay, so substitute this relation instead of V3 by V4. Okay, okay, V3 by V4 rho into R power. So actually gamma R power minus 1, here is our gamma, so we can say like this. So instead of V4 by V3, you can use this relation here. Okay, and similarly instead of P1 by P2, the process between 1 and 2, right? The process between 1 and 2, which is also again a adiabatic process, P1 V1 power gamma equal to P2 P2 power gamma. So we need a P1 divided by P2, which is equal to P2 divided by P1 whole power gamma. So again the thing, actually V1 by V2 is a R, so here's in terms of reciprocal, so we can say 1 divided by R, 1 divided by R power gamma, so which is we can say as R power minus gamma, right? So this equation you need to substitute here. Okay, right. Then so substitute both the relation in above equation. V2 into P2 into rho minus, just to follow the previous equation, the same thing I am going to write. Simply I replace the term instead of P4 by P3 and P2 by P1. P3 into gamma minus, substitute here this one. Okay, rho power gamma into r power minus gamma. Already there is the term r, so you can simply substitute use the same minus of p2 into 1 minus, instead of p2 by p1, here I can say r power minus gamma. Already there is a term r, so we can use like this, whole divided by gamma minus 1. Right? See, so instead of p4 by p3, I am substituting the term rho power gamma into r power minus gamma. We have here one more r, so like that here also we have here one more gamma. The same thing I used here. Okay, extra r, and here is a r. Okay, right. Then, so next what we have to do mean there is a further simplification. So actually here p2, here also p2, but here we are say using a p3. So due to constant pressure process, right, p3 we can say as p2, right? Just to replace the term. See, p2 into p2 into rho minus 1 into gamma minus 1, plus instead of p3 we can use p2 into rho minus rho power gamma into, so here have a r, here have a r, so simply we can say as r power 1 minus gamma, right? R power 1 minus gamma minus p2 into 1 minus, here also same base as r, so r power 1 minus gamma. So next, actually all the p2 p2 p2, so taking commonly outside p2 p2 and what's the remaining term, rho minus 1 into gamma minus 1 plus rho minus rho power gamma into r power 1 minus gamma minus 1 minus r power 1 minus gamma gamma minus 1. Fine. So next, so another simplification you need to follow here. So instead of p2 by v2, instead of p2 and v2, you can use some other relation. Okay, so this is considering the process 1 and 2, which is also reversible adiabatic compression process. So P1 V1 gamma equal to P2 V2 gamma. So here we, instead of P2, we can say like that, P1 into V1 divided by V2 power gamma. So V1 by V2 is nothing but R, that is a compression ratio. So P1 into R power gamma. So instead of P2, we can substitute the term P1 into R power gamma. Okay, and one more thing, we know the compression ratio equal to V1 by V2. So from this, instead of V2, you can form some other equation, or into sorry, what's that? See, we need a V1 divided by R, V1 divided by R, V1 divided by R. So we can say form right like this. Okay, so instead of V2 and instead of P2, you can replace the term here. So now we can write like this, P1 into R power gamma into V1 into R power minus 1, and remaining term is the same. Okay, gamma minus 1 minus rho minus 1 into gamma minus 1 plus rho minus rho power gamma into r power 1 minus gamma minus 1 minus r power 1 minus gamma. So the denominator is same, gamma minus 1. So next step is P1, B1, the base R is common, so R power gamma minus 1. Okay, the whole, just to multiply the term with this, with this. Okay, so rho into gamma minus rho minus gamma minus into minus plus 1. Then here, simply taking commonly outside, we can taking commonly outside as this term. So minus, so not commonly, just you can rearrange the equation, minus rho power gamma into r power 1 minus gamma, right? Mm, plus what's the term? Here is gamma. Just rewrite the equation. Rho minus gamma into r minus plus gamma. Okay. Minus 1 minus into minus plus r power 1 minus gamma. Right. So clear. Just I am rearrange the equation. So instead of first term, I use this one, minus rho power gamma into r power 1 minus gamma plus rho minus in 1 minus into minus into minus, so which form here is a plus or power 1 minus gamma. Okay, that is the thing. So next, whole divided by gamma minus 1. So next step is just to see if any of the parameter get cancelled here. So minus gamma here plus gamma get cancelled, plus 1 minus 1 get cancelled, and remaining term is P1 V1 into r power gamma minus 1 into rho gamma minus gamma minus rho gamma into r power 1 minus gamma plus r power 1 minus gamma. So this is the thing, whole divided by gamma minus 1. So see here again P1 V1 into r power gamma minus 1. So here taking commonly outside the term gamma here from this gamma, so remaining rho minus 1, right? So here from this r power minus 1 r power minus 1 minus gamma is common, so r power 1 minus gamma taking commonly outside, the remaining term is rho power gamma, so minus into plus, here I have a minus, again minus into minus, here is a plus, so minus 1. Okay, right. So next step is, that's all. P1 V1 into R power gamma minus 1 into gamma into rho minus 1 minus R power 1 minus gamma into rho power gamma minus 1 divided by gamma minus 1. So this is the work done calculation for diesel cycle. Okay, maybe this is equation number 6, I think so. So this is the simplified equation for work done of diesel cycle. So basic formula is, again, if you need to measure work done, which is nothing but efficiency equal to work done by heat supply. From that also you can solve. So depend upon the parameters given in a problem, you can use this relation. Okay, so next parameter. So next parameter is third one, mean effective pressure. Mean effective pressure. So the mean effective pressure general formula already we know that, which is nothing but work done divided by stroke volume or shaft volume, which is nothing but V1 minus V2. Okay, so the work done, so simply substitute here. Okay, divided by V1 minus V2. So here you can taking commonly outside the term V1. Okay, so P1 V1 into R power gamma minus 1 into gamma into rho minus 1 minus R power 1 minus gamma into rho power gamma minus 1 whole divided by gamma minus 1. Here simply taking commonly outside the term, sorry, not taking commonly, we know that compression ratio equal to V1 divided by V2. So instead of V2 you can substitute V1 into V2 equal to, sorry, V1 divided by R. So V1 divided by R. So next step, just to keep the numerator is same thing, and denominator is gamma minus 1, right? So here taking commonly V1, the remaining term is 1 minus 1 divided by R. Okay, so again the V1 term and above here have a P1 V1, so just to cancel here, and remaining term is P1 into R power gamma minus 1 into gamma into rho minus 1 minus of R power 1 minus gamma into rho power gamma minus 1 divided by gamma minus 1 into, so if you go for a LCM, R minus 1 divided by R. So here R power 1, if goes here means R power 1, so R power minus 1 and R power 1 get cancelled, so remaining term is the mean effective pressure equal to P1 into R power gamma alone into gamma into rho minus 1 minus of R power 1 minus gamma into rho power gamma minus 1 divided by gamma minus 1 into R minus 1. So this is the equation number maybe 7, I think. So this is the mean effective pressure of diesel cycle. So these are the various three parameters we need to derive for a diesel cycle. The first one is the efficiency derivation. Then we need to measure work done calculation and mean effective pressure. Okay, so equation number 6, 7, and I think so equation number 5. This is a simplified equation expression for a diesel cycle of mean effective pressure, work done calculation, and efficiency respectively, right? Okay, thank you. With this, we will wind up the section.